Okay, so here we have this interesting question. 5 raised by x equals 5x. Okay, so let's see how to solve the question. So what we could do here, we could equate them to y also. So you say equals to y. And of course, we know that if 5 raised by x equals 5x and 5x equals y, it also means that 5 raised by x is also equal to y, since they are both equal to the same value, and the value here now is y. So we are going to create two equations now. We're writing 5 raised by x equals y for equation 1, 5 raised by x equals y, equation 1, and then we are writing 5x equals y for equation 2, 5x equals y, equation 2, and then we'll solve them simultaneously. We could use substitution method. So let's make x the subject in equation 1. So write out your equation 1, which is 5 raised by x equals y. And the best way to make x the subject here is to log both sides. So apply log base 10 to both sides. So I have log 5 raised by x equals log y. So this power x here can move over to this side and stand in product with the log 5. So the x comes here. You now have x times log 5 equal to log y. So dividing both sides by log 5. So divide here by log 5 and also divide here by log 5. So log 5 cancels log 5. Then I know that x is now equal to log y over log 5. So x is equal to log y over log 5. Then I can now substitute the value of x into equation 2. So since x is log y over log 5, I'm fixing log y over log 5 for x in equation 2 here. So let me write out equation 2. So 5x equals y. So it will now be 5 into bracket log y over log 5 equals y. And then I will open the bracket. 5 times everything in the bracket, that's 5 times log y. It gives me 5 log y over log 5 is equal to y. Then of course I can put the y over 1 and then I'll cross multiply. So 5 log y times 1 still gives me 5 log y equal to y times log 5 gives me y log 5. And then from here, looking at this equation, we know that if we have a log b equals to b log a, it means that a is equal to b, or we can say log b is equal to log a. So that is the case we have here. 5 log y equals y log 5, exactly in this format. So we can say that 5 equals y, or we say y equals 5, or we can just say log y equals log 5 equals log 5. So whichever way, we still get 5. If we solve log y equals log 5, okay, let's try doing that now. If you solve log y equals log 5, you get 5. So let's do that. Log y, then the log 5 comes over to become minus log 5. Then you equate it to 0, since there's nothing on the right hand side again. Then from the law of logarithm, since they are in base 10, both of them pick one of the bases, base 10, and then divide the y by 5, since this is subtraction. So y over 5, then equate it to the 0 here. And of course, we know that 10 raised power 0 must give y over 5. So y over 5 must always be equal to 10 raised power 0. 10 raised power 0 is this. And of course, we can put this 1 over 1. Even the 10 raised power 0 is 1. So we can say y over 5 equals to 1 over 1. And then if you cross multiply, y times 1 is y equals to 5 times 1 is 5. You still get y equals 5. So now that we are sure that y is equal to 5, we can now substitute the value of y into equation 2 to get the value of x, because x is the variable they want us to find from the initial stage. So we now have substituting this value here. So 5x equals y, then 5x equals 5. So since y is 5, fix 5, then divide both sides by 5, then x equals 1. So, and it makes the equation true because 5 raised by 1 is 5 and 5 times 1 is 5. So that's it. And we are assuming that x belongs to members of integers now. So x is a member of integers. So that's it.